Intro to Stoichiometry, going over, again, the basic idea of the mole. Okay, remember that mole? Woohoo! No, it's not an animal. It's not something that you found on your neck one day and you got it checked out by the dermatologist. Okay, a mole is a number for counting. Yes. Technically, we would say it is for counting. Okay, a measurement is a quantity too. Okay, but mole is for counting. Let's just go back to the beginning, and we study this for the final. So hopefully this is second nature to you. Although some of us are still trying to remember this information. How many particles do we have if we have this so-called mole? Yikes. Okay, so that would be, see how hard it is for this stuff to come out of your brain? It's amazing. Okay, so 1 mole, if I were to count something and I got to a mole, I would have 6.02 times 10 to the 23rd. Now that was on the final. Unfortunately for this semester, we need to remember how to use this number using what is called dimensional analysis. And if you remember dimensional analysis, you'll remember that dimensional analysis is pretty much based off of canceling units. And this is going to be hard coming back to your brains here based on canceling units. Or you may be learning it for the first time. I'm not sure. Okay, based on canceling units. So if you recall, there's one kind of problem where you can actually convert. I'm going to use the word convert. It's a very important word. It means to change one number into a new number. That's what we're doing in this class right now. We're getting word problems with a number, and we can take that number and manipulate the number and turn it into a new one. Okay, so that's what we're doing. So one of the things we can do with what I just gave you is convert from moles to numbers of particles. That's a good guess, though. Remember, the number that I gave you, the 1 mole is equal to 6.02 times 10 to the 23rd particles, doesn't have the word grams in it, so you don't want to use it. Pay attention to the vocabulary. If I give you a question where I say from the moles to number of particles, stands to reason you'll be using that number I just gave you. So, in review, how many let's say atoms in, let me give you an arbitrary funky number, 0.29 moles. This thing's lagging again. So, if you remember dimensional analysis, some of you may not, very difficult. You write down the 0.29 moles. What comes next, if those of you remember dimensional analysis? Forgetting, times line. It's not even coming back to you right now, is it? It's like, oh my God. Anyway, so 0.29 moles. And if we were going to be like, super thorough with our work, we would say 0.29 moles of C and then the times line. And again, if you need to review your notes on dimensional analysis or watch this video 1,000 times, you need to get into your head that to cancel a unit, it must be in the denominator of a fraction. Okay, so the only way I can cancel moles, why are you canceling moles? Dimensional analysis. What's dimensional analysis? Converting units. How do I know I'm supposed to be converting? Because the question says, convert from number of moles to number of particles. Okay, so therefore, my reasoning states that something should go on the bottom of this line here. And if you understand what I'm saying, you would say on the bottom, you need to put the word. Very good. Always do that. You have to cancel a unit. That's the whole point of dimensional analysis. There's no reason to do any of this unless you're going to cancel your unit. You're converting. Like, how many dollars in a euro? You want your answer to say blank dollars, not blank dollars euros. Okay, so check it out. Boom. And what is the only other number we know that exists for a particular problem like this? There you go. 6.02 times 10^23. In this case, we'll say atoms. And what number goes in the denominator? 1. Remember that?
Yeah.
Hopefully. If you worked hard. Here's the issue. I've noticed a lot of people like to do less work in the beginning of a semester and catch up at the end. How well does that work in chemistry from your perception? It's extremely difficult. Especially when at the beginning I give you introductory information that is a basis for understanding the following information. So unfortunately, and this is where most teenagers need to grow and learn via other classes, in chemistry you want to do more work in the beginning and less at the end. If you're going to get lazy at any point, like the word lazy, you want to do it later. Right now, we got to hit the ground running. Okay? So I can see by the looks on your faces you're ready to do that. So, find a calculator. I have written the answer at the bottom. See if you can get that answer with your calculator. Part 2. Do you remember? No. The word. Okay, and this is where we may have had some issues. Molar mass, and that was one of the topics on our final, so I'll just go over it quickly. Molar mass, you look on the periodic table for the masses of all the elements in a compound, you add them up, and for water you get, for example, no, okay, 18, very good, thank you, grams per mole. Now remember, last semester, people got points for participating even though they said wrong answers. Okay, participation counts for bonus. Doing the study guide counted for bonus. If you didn't get any bonus points last semester, that's okay. But maybe at this point you're like, darn, wish I had some of those. Okay, so molar mass. What can we do with molar mass? Well, actually, this unit here means I have 18 grams of water in blank moles of water. There you go. So we can actually use that as a conversion. Now the trick with our sheet here is you may have to go backwards from these examples. Hopefully you understand canceling units to be able to figure out how to proceed when you're doing a problem backwards. So let's take our hypothetical problem. Let's say I have 2.8 moles. How many grams is that? So again, I start off with my 2.8. What goes on the bottom? On the top are grams, and that way, and it's always 1 mole. Do you see this? You saw I put a 1 there? 18 grams per mole. No matter how many times I repeat it, no matter how many times we play a game, or draw a poster, or do flashcards, or do a dance or a song, people always want to change this number when it comes down to a more complicated problem. But I'm here to tell you that molar mass in this fraction form is always 1 down there. Always. Always, always, always. Because that's the definition of molar mass. 18 grams per mole. 1. Very good. Devin's got it. Answer.
50.4 grams.
50 point. Uh-oh. Someone said wait.
No, wait. So you just do this just to write it out, but like in your head, you could just do 2.8 times 18.
Most people who do that will start failing when we get to more complicated procedures. So there is always a group of individuals who refuse the process because they feel a shortcut is better for them, and I always win in the end. Unfortunately, for me in this case, to win means for you to lose. And let's not have that, please. But I've begged and I've pleaded. And eventually when these problems become 5 or 6 steps long, and you are like, I can't cancel units, you will no longer be able to do it in your head. However, that being said, Elijah, you are correct. For the last final, you would have been fine getting away with just multiplying because you know how it works. Okay? That was great. However, the dimensional analysis part, this part here, you only got so much gas until you can avoid that topic. All right, so 50.4 grams or moles?
Grams.
Okay, and then I'll always put a box around it. Okay, so let's practice this before we go on to stoichiometry. Okay, just to give you an example. You don't have to write this down. But Elijah, imagine if I tell you you have 11 liters of a gas. How many grams is it in this hypothetical situation?
Oh. Like 22 point what?
You don't know this stuff yet. I'm just giving you an example. Say 2 mole of Y. Sorry. So that would be an example where you need to go from liters to grams, where you need to convert liters, do the mole ratio, and go back to grams. So you would lose track of whether to divide, multiply, okay? But that is, ladies and gentlemen, in weeks from now, okay?
Okay.
Yeah, weeks from now. So let's not get too preoccupied. However, the way to do that problem without screwing it up is the canceling that I'm trying to teach you. So we'll see more. Let's just practice.